Okay, I got a flu, and it has affected my voice. Okay, so I have very low voice now, and it's not so clear. So I think it's very difficult to reschedule a time for this class. So I decided to proceed. I hope that you can, I will try to do the best I can, but I hope that you can tolerate with all the iteration caused by my voice. Can you hear me, those people at the back? Those people at the back, can you hear me? Okay, good. Okay, last lecture we have started to go into Unit 4. We talk about requirement. We talk about requirement specification and also requirement general gathering in general. So I have given you some key points in terms of requirement gathering. It depends on the size of the projects. Okay, for large project, you may have to do it in a very formal way. For requirement specification, last week I also showed you a series of techniques from very formal, based on mathematical model, and very informal. Okay. So what we are going to study in this unit, the first modeling techniques we are going to study in this unit is a requirement specification techniques that is very commonly used. Okay. So this techniques is a very commonly used techniques for requirement specification under object-oriented approach. So the name of this techniques is use case techniques. So for today, firstly, we are going to study use case techniques. Okay, in use case techniques, we specify each usage of a system in terms of using the concept of a use case. That means each usage will be specified as a use case. Each usage will be represented as a use case. Okay? So how to specify a use case? We specify a use case by specifying the external interaction between system and the user. In this case, the user is a general user. It can be a hardware, it can be a machine, it can be sensor, it can be device, not necessarily a human. Okay? So whichever external entity interact with the system, we will represent it as an actor. So the actor here is more general. Okay. The actor here is a generalization of user. Okay, here show you a list of information, give you a checklist that you must cover when you specify use case if it is relevant. I'll leave it to you to go through the list. Okay, those people at the back, can you hear me? Very good. So, in use case techniques, the most important concept is that we will define each usage using we will define each usage as a use case, and we specify use case by defining all the interaction between system and the actor. Okay, now we start to look at use case techniques. In use case techniques, we specify the use case. Each use case is for specifying usage. So each of them, we will define a template to specify it. Later, I will show you the format of the template. The format of the template is fixed. So inside the template, there are many slots for you to fill in. Okay. We define the detail of each use case, that means of each usage, using a template. And we give an overview of all the use cases in the use case diagram. That's what we do in use case techniques. And at the end, the use case diagram and the completed template for each use case together will form our requirement model, will form our requirement specification. In other words, to specify all the requirements. Okay, so from the next slide onward, we are going to see the template, and we are going to see how to construct a use case diagram. Okay, this is a template. In this template, you can see there are many slots. Okay, so this is a template. This is the name. Under this template, there are a number of slots. 1, 2, 3, 4. You can count. Okay, quite a number of slots. And up to here are compulsory. From use case until exception are compulsory. From priority onward are optional. Okay, normally you will use up to, we will fill in only until exception. Here, this slot. The information for you to include in each slot is explained here. Okay, the first slot, use case, is for you to name the use case, name of the use case. Okay? So if it's to enter employee particulars, then under this case you will put enter employee particulars. So give a name of the use case. And after that, your primary actor, the main user, etc. Go in contact, you put the objective, okay? The purpose of the use case, the purpose of this usage. Every usage in a system, they must serve some purpose. Then we have precondition. The condition they must establish before we can start to use this use case, before user can start to use this use case. Okay? Trigger is different. Trigger is the events. So once the user can use this use case, each time when it is needed, the user will activate this use case for one activation. So trigger is to define the action or events that activate one particular usage, apply the use case. In other words, scenario. Scenario here is for you to include the mean. Just now I mentioned that we define a use case by specifying all the external interaction between system and the user. So scenario is for you to define the mean interaction. It means define those actions that will happen, those interactions that will happen when the user use this use case each time. Okay. So the common steps that the user will go through when he use this use case. Exception. So those steps, those interaction for dealing with error, exception, will not be included under scenario. They will be separately listed under exceptions. Okay? So that means scenario is for you to include all the common steps that the user will go through each time when he activates this use case. These are for you to specify those steps, action to handle exception, error, or option situation. Okay, the rest are optional. This one is to define the priorities, to indicate whether this one is on the highest priority, etc. And when available, schedule, frequency of use, how often, what is the usage, how the usage, it could be defined as per month or per day, etc. How many activation per day or per month the user will activate this use case. Channel to actor, the mechanism, the hardware that the user will use when the mean user, okay, the mean user is defined here. The channel, the mechanism that the mean user will go through in order to activate, in order to use this use case. Okay. Then the last two slots define information on secondary actors. Secondary actors are those users, they will not use it so common as the primary user, but they may also use it sometimes for certain reasons. So those users, we will indicate them under here. And channel, for those secondary actors, when they want to use it, what kind of device or what kind of mechanism they will go through, will be indicated here. The last slot is to indicate open issue. That means those issues that we still cannot resolve during requirement gathering. We have to clarify further. Okay, now we see an example on how to complete the use case template. We are going to, the next slide will complete the use case template for this particular usage of safe home security systems. Okay. Every usage will be defined as a use case. So, and once you define a use case, then you will complete a template to specify the detail of the use case. So the information of this particular usage are given here. So we are going to define it as a use case using a template by completing a template. Okay, this one is for a particular usage in safe home security system. Okay. This one is to, the main purpose of this one is to activate and deactivate the alarm. The alarm will, each time according to the homeowner wish. Okay. So there's one usage need to provide in safe home security system, that is initiate monitoring. That means initiate the system when the homeowner want the alarm system to activate, the alarm system. Okay, the homeowner, firstly, for doing so, the homeowner have to observe the control panel to see that they are ready. That means previous round, nobody make any mistake, leave it open. If they leave it open, then he cannot start up straight away. He will have to close them first. Then after that, if it's ready, then the homeowner will have to key in the password. The system will check the password. And so if it's correct, the control panel, okay. If his password is incorrect, the control panel will beep once and reset for further trying. This is the requirements. Otherwise, the control panel, if it's okay, then control panel will proceed to the next stage for the homeowner to choose which option the homeowner want to activate the alarm system, because there are two options here, either stay or away. There are two modes for activating this system. Okay. These are for different purposes. When the homeowner stay at home, surely the homeowner will not want to activate all the sensors, even those at home, because then anybody touch it, you will straight away activate. The alarm will still activate. So there are two different modes the homeowner will choose. Then when it's successful, the homeowner will have to observe that the proper, we have to confirm that he has activate the system correctly. Okay, with this information, we complete a template to specify initial monitoring. That is a use case in safe home security system. Okay, firstly, we put a use case name, as I told you. Permit actor, in this case, homeowner is the main actor because homeowner is the one who will activate the alarm system each time. Objective, the objective is very clear, is to set the system to monitor all the sensor, either when the homeowner is away or stay at home. Okay, precondition. Under what are the situations the homeowner must establish before he can use initiate monitoring? Very clear. The system must be installed. Okay. The system has been programmed for a password and recognize the sensor. That means the homeowner must configure properly, must install and configure properly before you can use it. Okay, before you can start to use this function. Okay. And trigger is different. Trigger is the events that activate each use of this use case. So each time when the homeowner decides to set a system, that is the trigger. Okay. So the trigger is a decision from homeowner to set up the systems. And scenario are listed here. Scenario are those common steps that homeowner will go through each time. Okay. So you can see from here very clearly that, okay, all these are the steps. Firstly, observe the control panel. Secondly, enters password, then select stay or away. These are the common steps. Each time when the homeowner wants to activate the alarm system, he will have to go through. Lastly, he will have to observe to confirm that the light, the proper light is on, red light is on to indicate safe home has been armed. Okay. The system has been armed. So these are the common steps the homeowner have to go through. And you can, so you will number them according to you will number them according to the order. Okay, and the format is the homeowner come first. This is always a format. So for scenario, always start from the main actor name, then after they have full colon, then after that, describe the steps. This is the format. All together here, there are 4 steps to go through. Exceptions. As I told you earlier, exceptions are to define those steps that not as common as those described in scenario. Exceptions are those to describe those steps to handle error situation, to choose option, etc. Okay. So first exception condition is the control kernel is not ready. When the homeowner wants to set up, he finds that he cannot set up because the control panel is not ready, because the previous round somebody has not closed it properly. Okay. So in that case, you will have. So the step he has to take is homeowner check all sensor to determine which one are open and close them. You have to check out what's wrong and close them accordingly. Then the second exception condition is the password is incorrect. In this case, the homeowner will re-enter, retry the password again. Password not recognized. In this case, it's due to incorrect configuration. So he will have to contact he will have to reconfigure it, monitor and response subject must be contacted to reprogram the passwords. Okay. And another one, the last 2 are options. Remember that the homeowner can choose 2 options, stay or away. Okay. When he chooses away, when the stay is selected, what should he do? Control. He should make sure that the control panel beep twice. This is the signal to send to indicate to the homeowner that okay, he has set up the mode, the option correctly as stay, and the stay light is lit, parameter sensor activated. So he will have to observe it when he chooses. When he chooses away selected, then the control panel will beep 2 times. Okay, that is a different sig, beep 3 times. So. And different light will be lit. Okay, this is the way to define, and priorities, all those are optional. Frequency of use, channel, the homeowner will set the system through control panel. And secondary actor, in this case, if there's any problem, if the homeowner cannot resolve it, he may have to contact support technician. Okay, so sensor will also serve as secondary actor because the initiate monitoring is connected to sensor. Okay? When sensor sense any events, external events, sensor will trigger the alarm. Okay, so these are the two secondary actor, and the channel for each secondary actor is indicated here. And these are the open issue. That means these are the problem, these are the issue that cannot be resolved during requirement gathering. Okay, there is so much on completing a template to specify a use case. Now we proceed to use case diagram. Just now we say that for each use case, we will complete the template to specify the details. And in addition, we will also draw a use case diagram to give an overview of all the use cases. Okay, how to draw a use case diagram to give an overview of all the use cases? Very simple. This one is the simplest. Okay, so every use case is represented by an ellipse. Later you will see an example there. In a use case diagram, we represent every use case as an ellipse. Human actor is represented by a human symbol. Okay, there are two types of actor. Human actor, we classify actor into two types: human actor and non-human actor. Human actor are represented by human symbol, and non-human actor we represented by rectangle. It is possible to have non-human actor because, as what you have seen in the earlier use case, the use case also interact with the sensor. Sensor are non-human actor. Sensor also interact. Sensor are external things that also interact with the use case, with the system. So each system user interaction is represented by a line. So all the interaction, we connect a line to show it. If payload clerk interact with this use case, we have connected a line from payload clerk to the use case. In other words, to show that there is such an interaction, to show that payload clerk is the user. Okay, the notation is illustrated in the next slide. Okay, so I'm going to show you a use case diagram to describe a system that have this 5 usage. Okay, safe home security system. This is from these are the 5 usage in safe home security system. Okay, so we define use case to specify each usage, and we draw a use case diagram. I'm going to show you how to draw a use case diagram for this system, for safe home security system. Okay. Here I also tell you that homeowner uses the first four, and the system administrator uses the last one, and the last 3 use case also interact with sensor. These 3 also interact with sensor. So very simple. This is the use case diagram to define the safe home security system according to the usage we have discussed. 1, 2, 3, 4, 5. 5 use case, we draw 5 ellipses for representing each of them. And homeowner is a human actor, homeowner is a human. So we draw a human symbol to represent it. He interacts with the first 4 use case. System administrator is also a human. We draw a human symbol to represent it and connect to the last use case to show that according to information given, because earlier you said that the last use case also interact with system administrator. Okay, the information given in the previous slide also said that the last 3 use cases also interact with sensor. Sensor is a non-human actor. So we draw a rectangle to represent sensor. And interaction are drawn by, are shown by line connecting the use case to the actor, right? So very simple. Sometimes we may enclose all the use case by a rectangle as such, but this is not compulsory. You may just leave it open without drawing the rectangle outside. Okay, now we come to, okay, this is so much on requirement specification using use case techniques. So we define each usage as a use case, and we specify each use case by completing a template. So if you have 10 use cases, you will complete 10 templates. And in addition to that, you will draw a use case diagram to give an overview of all the use cases. So these two pieces together, okay, a completed template, a set of completed templates plus a use case diagram together will form our requirement specification under use case techniques. We call it as a use case model also. Okay, the last few slides, I will give you some key points in terms of validating requirements. Once we have produced a requirement specification, okay, once we have produced any documents, any report, surely the next step is to check that we have produced the best report that we can produce. Okay, so similar in use case in requirement specification. Once you have completed a requirement specification, the next thing is we want to validate that our requirement specification is good enough. Good enough means it is correct. Okay, we do not miss out anything, and there's no redundancy, there's no inconsistency. So in any validation, when you produce a deliverable, then you will do a validation that is quite general. And during the validation, usually you need to perform 3 tasks: to check consistency, to check completeness, and to check correctness. Okay. Consistency means that your document as a whole, okay, do not contradict your document as a whole. Inside there's no parts contradict each other. That means if you produce a document with 100 pages, pretty simple, then all the requirements you have written in page 98 should not contradict with information written in other places. So checking the internal consistency. Completeness means whether we have missed out any requirements, some other requirement that the user also required, but we miss it out. Okay, so that's the completeness to ensure that we have specified all the requirements. Correctness means all the requirement has been specified correctly. That means there's no misunderstanding. Okay. So these are the 3 key when we do any validation task: consistency, correctness, and completeness. Okay. So so when you produce a requirement specification, you should also validate that your requirement is consistent, is complete, and is also correct. Okay. And for consistency, you can verify it. Quite a lot of consistency issue. You can verify it. The software engineer, the developer can verify it, can validate it among themselves by checking each part of the specifications. But for correctness and completeness, you will have to conduct review with the user to check with the user whether have you missed out anything or whether what you have specified is correct. There's no misunderstanding. That one you have to organize a review meeting with the user to go through. Okay, again, beside the main point, the next two slides will give you some checklist. Will give you a checklist. So I will leave it to you to go through. Okay, one of the things is that usually those things that I go through it very quickly are less important. Those things that I emphasize more are more important. That apply to knowledge as well as exam paper. Okay? So you may want to take some notes on that. Okay, now we come to the next behavioral modeling techniques we want to learn in Unit 4. That is the state diagram. So in state diagram, we model a software entity as a state machine, as a state machine. So the next question will be, what is a state machine? A state machine has a number of behaviors, have a number of states, and the machine will respond to external events to move from one state to another state. Okay, that is a general characteristics of state machine. I'm sure some of you have come across the term state machine before, because it's a very general concept, not only used in software but also used in hardware. Okay, a state machine means an entity that has a number of behaviors, and it will move from one behavior to another behavior in response to the events, to the external events occurring. Okay, so we are going to, in this techniques, we are going to define software entity as a state machine. So here I use the word software entity, means that depends on our need. We may define the behavior of each object in the class, as a state machine. We may also define the behavior of a use case by a state machine. We may define an entire system as a state machine. Depends on our need, depends on what we want. So the usage is very wide. Okay. How to define a state machine using state diagram? These are the basic components for defining a state machine using state diagram. In a state diagram, you will define state. Okay, you will define state transition. How a state machine moves from one behavior to another behavior. Okay, and you will also define events. What are the external events that cause the movement from one state to another state? So we will define this also. Lastly, very often when something happens, a state machine will move from one state to another state, and in order to move from one state to another state, a certain task will be performed that facilitate, that support the movement. Okay. So we will define those also as action. These are the notation to define a state machine we use. Okay, the notation is not very strict. Okay. We may have some variation. Sometimes we may use an egg shape. Sometimes we may even use a rectangle instead of rounded corner rectangle. The original notation is rounded corner rectangle. We use a rounded corner rectangle to represent a state in a state diagram. Okay? So this is one state, and this is original state, and this is a new state, in other words. And So this is the first component. And in addition to state, we have to define transition, right? How to define transition? This is the way to define transition, using arrow. Okay? Join from the original state to the new state. That means show that a machine, state machine, may move from this state to this state. Okay? May move from this state to this state. Okay? This is a possible transition. So each possible transition will be shown as a transition in our state diagram. And here is to specify events that cause a transition. So how to define events that cause a transition? We put it above the action. Okay. So events and action are defined together. Okay. Because action is always performed, we respond to the events, and that achieve the transition. So events is put on the top, and action is we put below, and we draw a line to separate these two. Okay? So the events, there's action which cause this transition. So the notation is very, very simple. Okay? And this solid ball with the arrow is to point to the start state. Sometimes, if we have a start state, we will use this notation to show that to show the start stage. Later, you will see an example. Okay, now we are going to see two examples on state diagram. The next slide will show you a state diagram, okay, to specify the behavior of control panel object. Just now we say that we can define a state diagram to specify each object in a class, because every class we only need to define one state diagram, because object in the class supposed to have same behavior. Okay, so that is one use of it. Another use of state diagram is to define a state diagram to describe the behavior of a use case. We can do that as well. We can also define a state diagram to specify the entire system. Okay. Over here, all this information are on behavior of control panel objects. This is behavior. Once the user start to hit any key, the control panel start to read password. The first thing, the control panel will read password. Then, after the user hit the enter key, okay, hit any key, the user will, the control panel will start to read in the user password. Once enter key is a special key, once the user hit the enter key, the control panel, that is to signal that the user has entered the whole password, and the control panel will start to check. To check, see whether the password is correct. If it is wrong, and the number of tries is within the maximum number of try allowed. It means this control panel, you can only try up to a certain number of times when you use this control panel. Okay. When you exceed that number of times, the control panel will be locked out. So when the password is wrong and the number of tries is within maximum number, then the user can retry. If the password is correct, then you will proceed to the selecting state. That is a different state. And so require function will be selected. The user can select require function. Then the details of all this, of how to select the require function, we can skip them. If the password is wrong and the number of try has exceeded the maximum, okay, as I told you, the control panel will be locked up automatically. And you will lock for certain amount of time. You will lock for lock time. Okay. So only after, once the control panel is locked up, it will lock, maybe if, depending on the lock time, maybe it will lock for 5 minutes. So it's only after the 5 minutes, then the control panel will release by itself, will free itself for other user to try again. Okay, based on the requirement, based on the information specified, so I define this state diagram to specify the control panel object. Okay, earlier on I told you that this symbol is to indicate the starting state. So that means hit enter with the events key, any key hit. When the user hit any key, you'll proceed to reading. Control panel will start to read. When the password is entered, that means when the user hit enter key, the control panel will start comparing the password to check see whether the password is correct. If it's correct, if the password is correct, okay, if the password is wrong, okay, apparently the mouse is dead. So the password is correct, you go to selecting state. Then, if number of try exceeded the maximum number of try, the control panel will lock by itself. Okay? Then, within lock time, the control panel will transit back to the same state. Within the lock time, means within the first 5 minutes, every time you transit back to the same state. No way to change it. No way. Then, if although the password is wrong, but the number of try is still has not reached the maximum number of try yet, the control panel will transit back to the reading stage. That means the user can retry, can enter the password, can retry a new password again. All right. So when activation, when selecting is finished, you go back to reading also for another usage. So this is the state diagram to specify the control panel object according to the information given in the earlier slide. Okay, now we come to another one. Photocopying machine object. Based on common understanding. Everybody knows that photocopying machine, after you fill up the paper and press start, you will go back to it, you will start to make copy. Okay? So this is the first stage. Okay, when it's done, you go back to the read photocopying again. Okay, when you look at photocopying machine object, that means to represent photocopying machine as an object, you can easily classify the behavior of photocopying machine into 4 states, right? Ready, that means you can accept user request. And another state is busy, making copies, right? There is another behavior. Then reloading paper, that means paper tray is empty. There is another behavior of photocopying machine. And the last behavior is problem stage, when the paper jump inside or there's other problem. Okay? So this is the another stage. So you can, when you look at photocopying machine straight away, we know that they are all together 4 major behavior, 4 major types of behavior. And we represent each of them as a state. And we show all the possible transition. Okay. When it's empty, when the paper tray is empty, definitely you proceed to reloading. Okay. So this is the action performed by photocopying machine. So that means the photocopying machine will invoke the reload paper task to tell the user that he must reload the paper. And after that, the photocopying machine will enter to reloading stage. Okay, so all the transitions are quite simple. When photocopying machine is making copies, it can transit, anytime it can transit the problem stage also. When paper is jammed, you will transit to this stage. When paper is jammed, the photocopying machine will invoke the problem diagnosis task to tell the user, to give user indication of what is the problem. Okay? And after that, when the user clear it, the photocopying machine will go to the ready stage again. This is a ready stage, okay, etc. So when it's full, after you reloading the paper, when the tray is filled up again, you will go back to ready, and the user can press the start again to continue to make copying. Okay, so this is the behavior. This is a state diagram to show the behavior of a photocopying machine object. In this case, it's based on our common understanding. I did not list down the behavior in detail because it's quite common. Okay, now we come to the last slide that I want to cover today. That is on, in practice, how to construct a state diagram. Quite similar to those other techniques that we use. Okay, usually we do it in 3 levels. The first level, we will classify the major behavior of the software entity we want to model into a number of types and specify each of them as a state. Okay, so this is the first level. The second level, after you have identified all the behavior and model each of them as a state, then we will check, verify to see whether what are the possible movement from behavior, on one behavior to another behavior. And we will model them as state transition. We'll draw arrow to show the transition. The last level, we will include the events that trigger the movement and also associated tasks that were performed when the events occurred. Okay. And write it down next to the transition. Write it down next to the transition. Okay, so the high the high level process for constructing a state diagram is quite similar to the way we do it for other techniques. Okay, today I will stop here. See you tomorrow.